Air conditioning, early spring, we'll move soon. We'll move into summer months. Question: with a split unit, with a heating and air conditioning unit, the topic is superheat. So, question: does high superheat indicate a low refrigerant charge? Again, does a high superheat number indicate a low refrigerant charge? There's a couple things to keep in mind. In the summer months, if one has a split unit, say the air handler under the house, in the closet, in the attic, the condenser outside, say if there's two separate copper pipes protruding from the wall or projecting from the wall, one copper pipe may have insulation, the larger pipe, the suction line. The liquid line would be the smaller line. The low pressure would be the larger line. The high pressure would be the lower line. Question: when measuring superheat, when taking numbers from a heating and air conditioning unit, one may a fictitious analogy is like a doctor or somebody taking perhaps blood pressure or stethoscope, using it on it. Well, the gauges could be the gauge for the heating and air, so to speak. So dispense with that fictitious analogy. But here the question is superheat and subcooling. Superheat is done on the evaporator side. Subcooling is done here. Low side, high side. Again, low side, high side. Blue low, red high. So just think of blue cool, red hot. Okay, if we take a superheat number, the formula goes superheat equals line temperature minus the gauge temperature. So the question is now, if we take and manipulate this formula, it may begin to tell us a few things. For instance, the A coil, if the A coil is around, say, 40, 45, 50, 48 degrees, that may be a good temperature. So it would be able to perform well under general situations. If the A coil or the evaporator coil drops below 30 degrees or 32 degrees freezing, then there's a problem, especially if the unit continues to run and builds ice on the unit, so more airflow is unable to go across the coils, so it just starts like a snowball almost. You'll start with a little small, and you keep rolling, it gets larger and larger. So when the ice accumulates, it gets more ice perhaps. But if we look at this gauge here and we go up to around, say, 50, whatever increments here, here's the 30 number. If we drop below this number here, if we're using an R22 refrigerant, say if we have 50, 50, 1, 2, 3, whatever degrees, PSIG, this outer ring is PSIG, either pressure per square inch gauge or pounds per square inch gauge, whatnot. That's neither here nor there, but when one takes the temperature, then you reference it across to what type of refrigerant. So if the gauge was reading somewhere in here, we would be at 32 degrees. So if we took, and the line temperature was, say, 70 degrees, and we took 70 minus 30, we would have 40 degrees superheat. So that would indicate a high superheat. So that perhaps could limit the fact that high superheat could portend a low refrigerant charge. There could be other things. There could be airflow. There's many different things. There could be bad fan. But let's just go up here and let's go the numbers up here. And let's say we'll go halfway in between. I'm thinking this is, say, 75 or whatnot. Or we'll go up here to about 78 or something. We come across here, we're reading 78 on the low side. We come across and it's 50 degrees. I think this may be considered saturation temperature. So 50 degrees temperature, this is PSIG. We come here, R22. So now say the line temperature is 70 degrees outside. So if the line temperature is 70 degrees, 70 minus 50, that would give us 20 degrees superheat. So the superheat would be lower. Now, if we move on up and we go to 100, we have 60. So technically speaking, if we take 70 and the line temperature was 70, 70 minus 60, that would give us 10 degrees superheat. So 15 is a good number. So right in here would be what we were shooting for. So about 75. So if we took about 75 and come across here, that and say 55, and the say the temperature here for the R22 would be 55 degrees. And if we took 55 and the line temperature, that's a little clamp you put on there. Now the heating and air gurus can, if they'll add this to the comments, technically speaking, I haven't used one of the little laser temperature things, and I'm wondering if a lot of other technicians, as opposed to clamping the meter on there to get the temperature onto the line, if they just take the laser and get the temperature from there. But that's something for the HVAC techs if they would like to comment. But say if we're around 75, we come across here, and then we're at about say 55 degrees here. So if we take 70 minus 55, that would be 70. That would be it's like, and so that would be 15 degrees superheat. So that would be about a good number. 15 degrees superheat may be a good number. So again, but if we go down here near the freezing point, if the pressures drop, if the PSI drops, it looks like the temperature is dropping. So if we took the line temperature 70 minus say 30 degrees, that's maybe 40 degrees superheat. That's extremely high. So yes, high superheat may indicate a low refrigerant charge. It's not the only thing that can contribute to ice and different numbers, but from a formulaic standpoint, a high superheat perhaps may lead one in the at least 0.1 in a direction that, so high superheat could be a factor of low refrigerant charge. Thank you for watching. Have a wonderful day. Thank you.